In order for two lines to be parallel, they must be drawn in the same plane, a perfectly flat surface like a wall or sheet of paper. Any line that has the same slope as the original will never intersect with it. This is another example to show the definition of parallel lines. The equations of two non-vertical parallel lines is as follows: y equals 2x plus 3y equals 2x plus 1. If two lines are parallel, then the slope of these two lines must be equal. That is, m1 equals m2, which is 2, where m1 and m2 are the slopes of the above lines. Here are some principles that included in parallel lines. So we go straight away to the proving. Given A and B is congruent to C and D, while A and F is congruent to E and C. So we gonna prove angle B, A, F is congruent to angle E, C, D. And the solution we have to consider and label further as follow. This is the proving steps that we have to list down. We have to write the statement and reason as well. One statement, AB, CD, AF, EC2. Statement, draw a line from point A to point C. 3. Statement, FAC, ACE4. Statement, BAC, ACD5. Statement, M, BAF equals M, BAC, M, FAC M, ECD equals M, ACD, M, A6. Statement, BAF, ECD. Properties of parallel lines. If two parallel lines cut by transversal, then the pairs of corresponding angle are congruent. Converse is when two lines cut by transversal so that angle are congruent. What is distance? Distance is the length of the space between 2 points. Example, the distance formula is a variant of the Pythagorean theorem that you used back in geometry. Here's how we get from the one to the other. Here is how you wanna find a distance. By the end you need to use Pythagoras Theorem. After plotting the point, you can draw in the lines that form a right-angled triangle. Using these points as two of the corners, it's easy to find the lengths of the horizontal and vertical sides of the right triangle. Just subtract the x values and the y values. Then use the Pythagorean theorem to find the length of the third side, which is the hypotenuse of the right triangle. Equidistant theorems are about the bisectors of lines and angles. They state, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment, by the perpendicular bisector theorem, and, conversely, if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle, and, conversely, if a point is on the interior of an angle and is equidistant from the sides of the angle, then it lies on the bisector of the angle. In a Euclidean space, the sum of measures of these three angles of any triangle is invariably equal to the straight angle, also expressed as 180 degrees. Radians, 2 right angles, or a half turn. It was unknown for a long time whether other geometries exist, where this sum is different. The figure above shows two pairs of alternate interior angles. For the pair in red, angle 1 equals angle 2. For the pair in blue, angle 3 equals angle 4. Now, take a close look at the figure below. I claim that angle x is equal to 85 degrees, so the sum is 180 degrees. To see why this is so, draw a line parallel to AC at vertex B. Angle A equals 65 degrees because it alternates with the angle inside the triangle that measures 65 degrees. Angle B equals 30 degrees because it alternates with the angle inside the triangle that measures 30 degrees. Looking at the figure again, it is easy to see why angle X is 85. Since the 65 degrees angle, the angle X, and the 30 degrees angle make a straight line together, the sum must be 180 degrees since 65 plus angle X plus 30 equals 180, angle X must be 85. This is not a proof yet. This just shows that it works for one specific example. Proof of the angle sum theorem. Start with the following triangle with arbitrary values for the angles. Since angle A, angle B, and angle C make a straight line, angle A plus angle B plus angle C equals 180 degrees. Since alternate interior angles are equal, angle A equals angle X and angle B equals angle Y. Therefore, angle X plus angle Y plus angle C equals 180 degrees. Interior angle of polygon. A pentagon has 5 sides, and can be made from 3 triangles. Its interior angles add up to 3 times 180 degrees equals 540 degrees, and when it is regular, all angles the same, then each angle is 540 degrees / 5 equals 108 degrees. So this is a general rule for interior angle of polygon. We show the shape from triangle until nonagon. But it can be bigger than that. There is sum of some interior angle formula. And how to find each angle of a regular polygon, we also share some example. Take a look. Exterior angle of polygon. The exterior angles of a polygon add up to 360 degrees. In other words, the exterior angles add up to 1 full revolution. 2 New congruency theorem in geometry. 2 figures or objects are congruent if they have the same shape and size, or if one has the same shape and size as the mirror image of the other. This is triangle congruence proving by using angle side. Take a look at the question and solution too. This one is the statement reason table. Look at every number. So that's all for our video about parallel lines, distance and angle of sum. Special credit to our beloved lecturer, Dr. Azar, for being patient all this while teaching us. Thank you.